Hello everyone. In this fourth video of chapter 2, we're going to solve one of the exercises of the lecture notes, exercise 10 that I'm sharing here with you what the exercise is about. This in principle is a very simple exercise whose main goal is for you to check that you've understood the main notions, the main definitions. So please, before you see the solution of this exercise done by me in this video, please pause the video and try to solve it on your own. If you have any problems, look out for the definitions again, look for the previous video and watch the last example that we did. And only once you have managed to solve this exercise, come again and see the reminder of the video where we see how this is done. Okay? Good. So let us read together what we have as a situation here. So we have two people, Alice and Bob, that are communicating between them, and they're using a simple alphabet reduced to only 11 letters, A, B, C, D, E, F, G, H, I, J, K, which are numbered from 0 to 10. Okay, and for the crypto system, they tell us that they are using the generalized Caesar cipher as encryption method, and the ciphering key is 5-3. Generalized cipher, Caesar cipher, and the ciphering key is 5-3. Okay, so whenever you start any exercise on cryptography, the first thing to do is to have a clear understanding of what is the crypto system that we're using here. And as we've seen in the lecture notes, if we want to know what the crypto system is, we need to know what are the message units that we're using and what is the enciphering transformation, right? Message units and the enciphering transformation. Enciphering transformation. Okay, so this should be clear here. Since we're using Caesar cipher, the message units are the letters. And the enciphering transformation is an affine transformation on the letters. So we go from Z over, we need to know what the modulus is. And since we have 11 letters, we're modulus 11, right? Z over 11Z. And if we have one letter or one number as an input X, the enciphering transformation, what it does is now using the enciphering key that is here, is telling us that we do 5X plus 3. Okay, and let's put bars everywhere to insist on the fact that these are numbers modulo 11. Okay, so this is the enciphering transformation, and this is the only thing we need to answer the first question, which is how to encipher the message decide. Okay, so let's work on this first question. Question 1, we have the message decide. We know what the enciphering transformation is, so we simply need to apply it. So we will just need to transform each of the letters here into a number. So decide, let us write them all here. And as numbers, so D, if we come back to here, we said D was 3. E is 4, C here is 2, I is 8, I is 8, D is 3, and E is 4. Okay, so in fact, as you see, to cipher the message decide, we only need to do the computations for the first 4 letters, since the second part, the second D and the second E, will give the same result as in the first 2. Okay, good. So now we have these 3. Now we apply the transformation here that we call the enciphering transformation, right? We apply this here. Okay, enciphering transformation. Let us put this in some color to insist on the fact that doing something. The enciphering is the blue part here. Enciphering. Okay, enciphering. So we just apply the formula 5x plus 3 for 3. So that makes 5 times 3, 15 plus 3, 18. But we are modulus 11, so 18 is the same as 7. Okay, and 7, if we look at which letter it corresponds to, is H. So the first letter of the message of the ciphered message is H, which is the same here for the second one. So we don't even need to do this one, right? This is again 7, which corresponds to H. Okay, let's do E. Same calculation. We do 5 times 4, it's 20, plus 3, 23, modulus 11. This is the same as 1, right? 23 is 22 plus 1, and 1 corresponds to letter B. Okay, so here we have, again, E, we have already computed it here. Okay, here we have 1 and B. And now there's only 2 letters left to do. So letter C is 2, 5 times 2, 10, plus 3, 13, modulus 11 is 2. So we see that letter C remains unchanged. When we cipher it, it becomes C again. And finally, the 8 here. The 8 here. So it's 5 times 8, 40, plus 3, 43. Modulus 11 is minus 1, therefore the same as 10, right, for I, which means that 10 is letter K. Okay, letter K here. Okay, so therefore the ciphered message is the ciphertext that we find in the end is just H, B, C, K, H, B. Good. So that was simple. That was how to cipher using this generalized Caesar cipher. Now, question 2. So again, you can pause the video here and try to solve question 2. Now that you have seen how to solve first question, and then resume the video. So now we need to decipher the message BGGKCDCB. Okay, that's what we need to do. So method 2, and for that we need the deciphering transformation that we have not written anywhere, right? We have talked about how to cipher messages using the enciphering transformation, but we don't know how to decipher, right? So if the ciphered message, we just need to find what the deciphering transformation is. So if the cipher, let's call Y the ciphered message, cipher unit, ciphered message unit, and X is the plain message unit, we know that the relation that they have between them is that Y is the enciphering transformation of X, right? But we also know that it goes in the opposite direction, that X should be equal to the deciphering of Y, right? And we know that Y, the left part we know that this is, we know that Y is equal to 5X plus 3, right? So now we just need to isolate X in this equation to find what the deciphering transformation is, and therefore this is quite simple. We pass the 3 on the other side, so it becomes 5X is equal to Y minus 3 modulus 11, and the only thing we are left here to find the deciphering transformation is what is the inverse of 5, right? So this is the same as saying that X is equal to the inverse of 5 times Y minus 3, okay? To find the inverse of 5, well, we just need to find, so we can do this in various ways, right? We look in the inverse of 5, so the inverse of 5 here, this is this you should know how to do from the first chapter. The inverse of 5 is such that 5 minus 1 is equal to 1, modulus 11, right? And this is quite simple. You can just try all numbers, or you can do with the extended Euclidean algorithm if you want. But here, for example, you can notice that 5 times 9 is 45, and 45 is equal to 1 modulo 11. So 5 minus 1 is the same as 9. Okay, here, because 5 times 9 is 45. Okay, so therefore we have here that x is equal to 9y minus 27, 3 times 9, right? And 27 modulus 11 is minus 5. Minus 5 is the same as 6. So 9y plus 6. Okay? And now that we have the deciphering transformation, so we have the deciphering transformation. Let's write it down here. So we have it here. Now we can just apply this transformation to the word that we have to decipher. So let me write it down. BGGKC, BGGKC, and then the last KC, DCB. DCB here. Okay, so now we translate this into numbers. This is number 1. J is number 6. J is 6. J again is 6, so we don't need to do this twice. K is 10. C is 2. D is 3. C is 2. And B is 1. Okay, and now we just apply this modulus 11, right? So let's decipher here using the red letter for deciphering. So let us do this deciphering of all these letters here. Okay, so let us apply it for the first one. For y equals 1, 9 times 1 plus 6 is 15, and 15 is 4. So this corresponds to letter 4 is letter E. Okay, letter E. So therefore we already know that the last one is also letter E here. Good. Now 6 we do for G. 9 times 6 is 54 plus 6, 60, and 60 is 5 modulo 11. So that's F. Same for this one. F here. Now we do for K equals 10. So it's 90, 96, and 96 is 88 plus 8. So this is 8. And 8 corresponds to letter I. Okay, letter I here. And now we just have 2 more letters to do. 9 times 2 is 18 plus 6, 24. 24 is equal to 2. 2 we know is letter C. Okay, and so we have again here 2, and the last one to have the word we're looking for, which is quite obvious here. We don't even need to do this. Is efficace, right, in French. So for D is going to be 0. Okay, so the plain text here that you had to find, plain text, is efficace. Okay, for this exercise.